Welcome back, everyone. I hope you enjoyed that last session. So our next session today is the history of valve insertion and its future by Brandon Pater. Brandon graduated as a civil technologist from BCIT in 2008 and has 12 years of industry experience as a field engineer, superintendent, project manager, and now as co-owner of Pacific Flow Control. He acts as a liaison in the design and implementation of standard and specialty hot taps, line stops, valve inserts, freeze plugs, and engineered fittings. Brandon brings strong technical and practical knowledge to the world of engineering and construction within live water and sewer infrastructure. So please welcome Brandon.
All right, thanks, Chris. Hi, everybody. Thanks for joining us from your home or work office. Hopefully the conference is going good so far. So yeah, as Chris was saying, I'm Brandon with Pacific Flow Control, one of the hot tapping companies here in Western Canada. One of the questions we get on a fairly regular basis is, I need a valve insert. There's so many on the market. They all look very different. Which one do I choose, and why should I choose that one? So decided to come up here, and I'm going to do my very best to give you a very non-biased opinion. I'm just going to show you all the different valve insertion technologies. I'll let you know the way they work, the way they go into your system, the way they operate, and then hopefully you guys can make the decision from there. We'll also go into a little bit of the history and try and see what the future potentially looks like for this relatively up-and-coming technology here. So that being said, let's get right into it here. So this is normally the part where I'd be looking at an audience and say, hey, put your hands up if you guys have done a valve insert before, you know what a valve insert is. I don't have that opportunity here today, so I'm just going to guess that probably about 70% of you guys know what a valve insert is and have had some experience with them. And the other 30% of you have no idea, and I'm potentially speaking Greek to you right now. So essentially what a valve insert is, you have live infrastructure, water or sewer or natural gas, really whatever it is, it's live, and you say, I need a valve. There is no valve here, and you have a hospital on the line, or you just have a whole neighborhood downstream that's going to be shut down. I need a valve for redundancy or for whatever reason to repair a leak downstream, and I have no way of doing this without shutting down important or high number of clients. So I picked a video here. The video has it's just the best video that shows kind of how the valve insertion works. So we'll go through it, and after it you should have a pretty darn good idea of what a valve insert looks like. So this particular valve insert is a ductile iron body going on the pipe here. It's MJ style valve insert. We'll go through the different types of valve inserts as we move along here. So the MJs go in, and I imagine most of you guys are familiar with hot taps. Pretty much whenever you access live infrastructure, you do so through a hot tap, and part of that hot tap is having a valve, in this case a temporary valve. So you're going to put that valve on, open it up, and do your standard hot tap on it. This particular valve insert actually removes the entire piece of pipe, so you're going to cut that out. Again, your infrastructure is live during this whole process. Close that valve to isolate, and then you're going to pull this coupon off. So on the nice thing about this style is if you do that, and that's cast iron, it's actually probably going to be full of tuberculation and all that sort of stuff that you've just removed from your line. This is your sweep or vacuum tool. This is going to go down and use the pressure in the system to actually suck out whatever shavings fell to the bottom your body there for to leave you with a nice clean valve seat. It's the valve cartridge setter, so that's now going to go on. Again, using your valve to isolate, you'll open that valve, drop that valve cartridge in. I don't know if you guys have seen a line stop before or not, but similar to setting the completion plugs in a line stop, those set pins are going to go in from the side there. That's going to temporarily hold that cartridge in place. And then that's going to allow you to remove your equipment offline. And then you're going to put a completion ring on there with a double gasket seal for final configuration there. So that is kind of the basics of a valve insert. Putting a live valve in where no valve existed before. And now we'll move on. So again, if I had a live studio audience, I'd say, hey, when was the first valve insert invented? And some boisterous guy would put up his hand and guess 30 years. And I'd say, that is a great guess, because that is in reality when everybody started seeing these things pop up, especially here in Canada. But in reality, this is a very old technology, similar to hot tapping. Hot tapping first came around in the late 1800s, 1890 something. And believe it or not, valve inserts weren't very far behind. So AP Smith actually did the first 6-inch valve insert on 6-inch cast iron in 1905. Actually, believe it or not, we still use AP Smith hot tapping machines. A lot newer than 1905, luckily, but a pretty common name in the hot tapping, line stopping valve insertion industry. So AP Smith was around for a long time, almost 100 years, doing the valve inserts. And between 1905 and the early 90s, when they started discontinuing their line, they actually went all the way from 4-inch all the way up to 52 inches. And these were monstrous double disc valves, weighed as much as or more than a Cadillac. Took a crew of 6 guys to install. And kind of the process that AP Smith had set up is they would actually send the equipment out with a technician, and you'd send your guys in to help them. We actually used to help do some of those AP Smith valves in Seattle in the late 80s, early 90s. Then along, it's really hard to know when Mueller first started. The first documentation I could find of the first Mueller insert valve was 1957, but somewhere in the mid-50s, Mueller came out with the Mueller H2300, which was the first valve that actually allowed tapping contractors and municipalities to kind of do it all themselves. 48 inches, that also went on till the early 90s, and then we kind of had a lot of change. Lots of valve insertions started coming out, and that's where guys, started getting confused because there's so many different valve inserts on the market. So in 91, that's the black one there, the Romac quick valve came out, and the insertive valve. In 1995, the one below the quick valve there, the HydraStop came out with their first generation. Then 2003, the Team Valve first came out. Then 2010, the AVT Easy Valve came out. And now in 2021, Mueller, just before COVID kind of hit us here, Mueller announced that they're coming out with a new valve insert as well, which I think they're going to hold off till 2021 now to actually release it once COVID's calmed down a little bit. But lots of valves on the market, and unlike a Mueller, a Clow, a Terminal City that all look the same, act the same, have the same connections, these all have very unique installation methods and different ways of working in your infrastructure, which just kind of creates confusion among the guys wondering which valves to use. So we'll go through each one on a one-by-one basis and see if we can decipher them a little bit here. The first thing to go over is the valve insert itself and how it sits within your system. So the Easy Valve is over there kind of on its own. It doesn't use a hot tap off the top. It actually uses a router style installation. So you'll router out, and we'll go through each one individually in a few minutes here, but you'll router out this section of pipe and you're left with that slot style hole in the pipe for your gate access. The HydraStop and the Romac valves, that is just a single hot tap from the top. But what those three valves have in common is they all use your existing infrastructure for the gate to seat in. So your AC pipe, your C900 ductile cast, they're using that pipe infrastructure to seat in, and then through different mechanisms that gate will seal within your pipe infrastructure. The Mueller, the new Mueller valve and the Team valve, they actually, as you saw in that video, cut out that existing pipe infrastructure and seat within the valve body itself or the cartridge itself. And we'll move on to that in a minute. A lot of people right away go, oh, that's for sure the better method, and definitely sometimes it is, but other times it's not always, and we'll get into that right now. So the first valve insert we'll talk about is the AVT Easy Valve. So this one is quite unique in the installation process. So I don't know if you can see in step 1 there where you see the black rubber above the casing there. So that is actually the gasket material. So the gasket material kind of wraps around the pipe. Then blue valve body clamps around it. A machine goes on that's going to turn that valve body, as you can see in step 3 there, and the router's placed on top. So there's a built-in valve there. If you can see it on step 2, there's a built-in valve that stays with that valve permanently. You'll open it, you'll put your router on, turn it on, lower it, and then you're actually going to rotate that entire valve 120 degrees to rotor out that system, as you can see in step 3. Once the system's routered out, you'll lift the router, close the valve that's built onto the system, put the head on, and then open the valve to drop your gate, and there's bolts on it that rest against the pipe, and that's how you'll center that valve at the end of the day. So a little simplistic approach to how this valve works, but I think most of you will get the idea of it fairly well. It's pretty straightforward. Moving on to the next valve. So this is the HydraStop valve. It's very similar to just a basic hot tap in its installation. Clamp style, hot tapping sleeve clamp style body. Really nice for AC pipe because it's kind of self-restraining. So you'll put your temp valve on, put your hot tapping machine on, you're going to cut out that piece of pipe, close your valve, put the valve cartridge on, set pins, blind flange on top, and you essentially have a new valve in your system. Fairly quick to install, 2 to 3 hours. I guess the one thing that's good to know about the HydraStop valve is what happens is you have different cartridges per different ID size. So, and these cartridges have limited range, say a 1/4 inch or so. So if your ID is nominal, say on a 12-inch pipe, it's 12 inches, you'll have to get a cartridge for 12 inches. If it's undersized because you're using DR11 PVC, you're going to have to know the ID of that pipe because you're going to have to order a different cartridge. So one of the downsides about this valve is that you actually are going to have to do a test tap to know the ID of that pipe in order to order the right cartridge ahead of time. And sometimes that comes with some additional expense to expose that pipe and do that test tap, or to bring in 2 or 3 different cartridges. Next valve, the HydraStop. So the installation method's similar to the previous, very similar to a hot tapping sleeve, which again is nice on AC pipe that you can't restrain against. And it's going to clamp around that pipe. Again, temp valve, hot tap it. The difference is this one you won't need to know the ID of the pipe because they use, and you can see it there, there's a red mark around it actually still from when I was going through this presentation earlier. There's what's called a reamer there. So that reamer is going to go in and it's like a big head with blades around it. It's going to go in and fit the ID of that pipe. So it's going to ream out that pipe to the exact ID that it needs in order to fit the valve gate. That's nice because you're not going to need to know the ID of that pipe prior to purchasing that valve. The unfortunate thing is that it means there's a bunch of additional shavings brought into your system from the reaming process. Typically not a big deal. Lots of municipalities will just open a downstream hydrant during the hot tapping and reaming process and flush as they're hot tapping. Sometimes for all the valve inserts, but especially for the quick valve. Or alternatively, if you're not too worried about it and you know it'll just come out with your annual flushing program, you'll just make sure if there's PRVs or anything like that downstream that you'll clean those screens ahead of time. I mean after the hot tap. So the next one's the team valve insert. I don't need to go into too much detail with this one because you guys saw the video on it, but similar process. The only difference is it's MJ style. So instead of having the hot tap style clamp there, it's actually going to have two MJs on the end, making a pressure capsule that you will put your valve in, and then that gate will seat against the valve body itself. Last one here is the Mueller H2300. So this one, again, to be released in 2021. Very similar. It's funny because I always want to say it's very similar to the team valve, but in reality, the team valve is very similar to the original 1957 Mueller H800. So this is the Mueller H800 reimagined for 2021, I guess. And very similar to the installation method of the team valve, though. Again, it's MJ, so you make that pressure chamber, you hot tap out the entire piece of pipe, and then your valve cartridge goes in. This cartridge is a little different, though, where the team valve seats on the bottom of the valve body. Hopefully that makes sense for you guys. This cartridge actually has a bottom. If you look in step 3, the bottom of that cartridge, it actually has its own bottom. So that gate actually seals within the cartridge itself. And that's because Mueller, when they built this one, they wanted all their 2300 series valves to be fully interchangeable. And in order to do that, they had to make the gate seal within its own unit so it can be a standard Mueller 2300 series gate. And it also gets rid of the low spot in the valve too, which is nice because no debris can settle there. All right, how are we doing for time here? I think I'm good. So the big thing is, what's the difference? Which valve's right for me? And I'm not going to be the guy to tell you which valve's right for your unique situation because you guys are the ones who know your infrastructure much better than I know your guys' individual infrastructure. But what I'd like to do is just go through all the valves individually, and you guys can try and figure out which one's right for you. And just a few things off the top, I'll kind of run across for each. And starting with the bodies. So the Mueller valve, they're more robust. They're big, heavy, ductile iron bodies, which is typically great. It usually means they're nice and rigid. They got a lifelong, long life expectancy, and they can survive that horrible underground existence that they're going to have for the next 50 years. But that being said, it does make them heavier valves, and if you are on brittle, old infrastructure in a boggy area, like Richmond or Delta, for instance, or some sort of bog or floodplain, the Romac quick valve, the HydraStop, having those lighter valves where you're worried about pipe shear, sometimes that is an asset, especially because, and some guys will say, oh, just pour concrete under it. And when you're worried about pipe shear, the last thing you want to do is pour concrete under that valve and induce even more weight into that system. So the Romac quick valve, carbon steel tapping sleeve, very similar to the Romac tapping sleeves you typically see. Long life, 50-year life expectancy, just like anything. And a little bit lighter weight. The HydraStop 304 stainless, which is good if you're in really corrosive soils. And then it's a combination of rolled steel and cast steel. AVK, epoxy-coated cast steel. The team valves, ductile iron body, same as the Mueller H2300. So the size ranges, the Romac quick valve's good between 4 and 12 inches, but 4 to 8 inches, this is a bunch of information. 4 to 8 inches follows AWWA 3 turns per inch. The 10 and 12 inch is on a spur gear, so you're up to 260 and 305. I'm kind of guessing at those numbers on the 10 and 12. So some guys are okay with that. Other municipalities want everything to be standard AWWA geared valves. The size range for the HydraStop, 4 to 24 inches, but 20 and 24 inches go to a ductile iron body. The Easy Valve to 4 to 24 inches. This being said, when you get up into the larger range valves, especially 20, 24 inches, you'll have to grab a pen and paper and do real cost analysis because line stopping or potentially nitrogen freezing even sometimes in those larger diameters might be a cheaper option. Team valve 4 to 12 inches and the Mueller will be 4 to 12 inches next year too. Pressure, Romax 150, the rest are 250, and then the Mueller's 350 PSI, highest out there. Bodies we talked about, and then the restraining we kind of talked about too. Clamp style. Again, if you're on AC pipe, we do a lot of these on AC pipe naturally because guys are trying to limp their AC systems forward for another 10 to 20 years, and they have 0 working valves left in the entire system. We've been in multiple cities now that have, or towns that have 0 working valves in their system, which means every water leak, they're pretty much shutting down the entire town. So those are, where was I at? So the clamp system. Totally lost my train of thought. Easy valve, carbon steel, and then the ductile iron. Stems, hardware, everything's available in 304. And then the cost, which everybody cares about. So everybody's on a budget, of course. The Romac is your cheapest valve, and that's why we sell a lot of them, especially guys trying to, like we were talking about earlier, limp their systems along. If you're trying to get another 10 years out of your system, it's fairly low pressure, 150. Lots of guys are going with the Romac. The next 3, mid-level, and then with the 350 PSI pressure rating and the 316 stainless steel and the 10-year warranty on the Mueller, I think it'll naturally be the more expensive of the valves. All right, so I get asked this question all the time. Valve insertion, where's it going? What are the new products coming out? And to be totally honest, if I knew the future, I wouldn't be here right now. Not that I don't want to be here, but I would be on a day trading floor in New York on the New York Stock Exchange, probably making some real money. But I don't know the future, but you can kind of predict where it's going. And I think more and more clients are running into the problems. They don't have working valves, or they don't have enough valves because what was once a bunch of farmers' fields is now high-rises and multi-unit family dwellings. And they've now realized they have kilometers between valves, and where they used to be shutting down 4 or 5 houses, they're now shutting down, hundreds or thousands of people, especially as you move closer to Vancouver. And So valve inserts is seemingly going to be the answer to solve a lot of these issues, and guys want to know, what's the future going to look like. And I think clients are really asking more and more for a fully spec'd AWWA valve insert, and I think over the next 2 to 10 years, more and more AWWA spec'd valves are going to hit the market on the valve insertion side, and you'll be able to take advantage of that in full. I think that's all I got for you, and I guess I'm ready to take questions.
Thank you very much, Brandon. That was a very informative session. That was great. We have a couple questions here. One is, what is the potential for shavings to enter the live water system?
Yeah, so shavings will enter your system unless the water's completely stagnant, which if the water was completely stagnant, you probably wouldn't have to have us out there to start with. So shavings are going to enter your system for sure. You can, if you are nervous about shavings because you have instrumentation downstream or anything like that is sensitive to shavings, you can open the hydrant. If you open the hydrant and flush during the tapping process, that will get vast majority of the shavings out of there for sure. Most municipalities just figure the shavings are going to come out with their annual flushing programs, and all hot taps, any hot tap you have will come with a certain amount of shavings. That being said, what we've found in the past, and you guys all know because after you're done flushing your system, you get all these phone calls for the next few days. My faucets are running brown. My faucets are running brown. Shutting down a cast iron system or an AC system and then repressurizing it is going to stir up more crud and junk on the bottom of the system than the shavings are gonna have with materials entering the system. So you are gonna get shavings, but I would think it's the lesser of the two evils of shutting down a system and repressurizing it, and then cracking that valve and stirring up all that material as you go along versus doing that. So if you are concerned about shavings, I just crack a downstream hydrant if possible and run it out into a screen. Good question.
Thank you. Where would you possibly order these from, and where do you get the hot tap machine from?
So there's a number of, for the most part, you could go to one of the manufacturers and buy the valve insertion equipment yourself. There would be a decent amount of expense to it. I think for the most part, the guys in Western Canada are going through one of the tapping contractors. There are a number of us around throughout BC and Alberta. I think there's probably 3 or 4 of us that probably do the valve insertion.
Is there a way to remove existing valves and install new ones?
Yes, there is. That's a different presentation though, but if that'd be a line stop. So, and that's a really good point actually, and I can elaborate on that more. So we get phone calls all the time. Guys will say, hey, I got a broken valve in my system. Can I get a valve insert put in? And we're happy to do it either way. You can put a valve insert in and just abandon the old valve, but I know a lot of municipalities like to do what's called a double line stop. So you would do a line stop. Essentially it's a tapping valve, and you insert a mechanical plug on either side, remove that old valve, and put a new valve in its place. If you go to YouTube and you just Google search hot tapping, line stopping, you'll get dozens of videos on what that process looks like, and it'll take you through that. So we typically leave it up to the municipality, but on our end, you can do the double line stop, pull the valve out, which is what I would actually recommend if you have broken valves in your system, or you can do a valve insert and just abandon that old valve. And it's, again, you may need to pull out a pen and paper and do a little bit of cost analysis to see what's the better option for you.
Okay, next question. We use Mueller, but still use concrete to set in for hammer at the T on AC pipe. Could we use a different valve?
Your MMCD will always call for your concrete thrust blocking. There's a few cities that don't do concrete thrust blocking. They do full restraint. The only one I can really think of, I know Richmond and Delta, especially when you get in the real boggy areas, they won't do they'll restrain everything versus concrete thrust blocks in order to stop that pipe shear from happening. But most cities just follow MMCD concrete thrust blocks, and it's not the valve that'll dictate the restraint, it's your restraining mechanism. So whether MJ or hub or flangeal, you can get restraints on all that. On AC pipe, did he mention AC pipe? Yes. Yeah, AC pipe is always tricky for restraint. You're really just kind of stuck with the concrete thrust blocking for the most part. There are a few guys that do make concrete that would make AC restraints. I know you might want to talk to Dave from USC. I'm sure Smith Blair has some sort of AC restraint systems that would replace the concrete blocking, but it's going to be costly. And if you're in an area with good ground conditions, I would think concrete thrust blocking would be the way to go still.
Thank you. There is another question here asking about getting a copy of the video for training. Is it online?
Yeah, if you go just to YouTube, you can search the team valve insert, and that video will come up. Actually, that's a great point. That being said, if you are looking to potentially be doing a valve insertion program or anything like that in the future, all the manufacturers here have videos for each product. I'd encourage you to look at each product. And I'm sure the questions also come in, which valve insert would you recommend? And I'm not going to put my name on a certain one. If you want, feel free to call the office. I'm sure a senior technician will be happy to talk you through it. But I would encourage you to remember that salesmen are trying to sell their product, and if it looks fishy or it looks too good to be true, just use your better judgment. If it looks a little Mickey Mouse, there's a good chance it is. So good. Any more questions?
We got one more. Are there sometimes problems with valves not seating completely against the existing old pipe? Like
yes.
Example, valves that aren't full section removal.
So that's a great question, and I actually, when I rehearsed this originally, I meant to bring that up, and I totally forgot, so I'm glad you brought that question up. So this is why actually the Mueller valve currently, when it comes out, is going to be the only valve that actually is going to warranty a bubble tight seal. So to date, all 4 other valves on there have what they've said is they guarantee a workable seal. And the definition of a workable seal is very is very different to different people, and it's a very vague terminology that we really don't like. But they guarantee a workable seal, and what a workable seal is usually, in what I would define a workable seal is, at least when we're doing line stops, is a garden hose worth of water bypassing. That being said, we've done hundreds of valve inserts over the years, and 95% of the time you get, a bubble tight seal or darn close to a bubble tight seal. You will get blow-by on valves from time to time. We actually have one right now that we're having trouble with because it's blowing by on us out in the interior there. And it does happen from time to time. I'd say probably about 5% of the time it blows by, and then maybe 2% of the time it's blowing by more than what I would think is a workable seal, but the manufacturer will still call it a workable seal. This being said, you are right when you say, do we ever have trouble with the workable seal? When we have troubles with the workable seal, it is typically the valves that seat within the pipe, and it is typically the valves that aren't reamed, which I might have pointed you towards the two valves, but those are the ones we would typically have more trouble with. But that being said, none of those manufacturers will guarantee anything outside of a workable seal. So when the Mueller valve comes out, that'll be pretty exciting for us in the tapping industry here, that we have a valve that can now be installed and actually hydrostatically tested against. Great question. Yeah, and I'm sorry I missed that. I should have covered that in my presentation.
We got a late entry here. One more for you. We have some valves that work fine but have high corrosion. Is there a best practice method to restore the valve?
Good question. So if they are, there's actually a company that deals with this. It's a Xylem company, I believe. I believe Pure owned them, and then Xylem bought Pure. But it's called wastewater. And for large diameter valves, yeah, it's definitely potentially, and when I say large diameter, I really mean like 24 inches and larger, because you will need a shutdown to reinstate these valves. But it's worth calling Justin at Pure Technologies. He could probably help you out with that. For anything smaller, smaller than 24 inches, even maybe 24 inches, you're probably looking at, if they're heavily corroded, you got a few options. But if they get a full seal, you can do a nitrogen freeze on both sides and pull that valve out and put a new valve in, or do a line stop on both sides and pull that valve out, put a new valve in, or a valve insert. But if they're 16 inches and below, I would think they're most definitely cheaper to just pull out and put a new valve in than it would be to have a company come in and remachine the parts for it and everything. It wouldn't be worthwhile. Unless it's limited to the bonnet. If the body's in good shape and it's just the bonnet, then potentially shut her down, pull the bonnet out, and throw a new one in. Good question.
Thank you, Brandon. And on behalf of the EOCP, thanks for joining us today. That was a great presentation.
Perfect. Thank you.
And for everybody watching today, we're going to have our coffee break, and we will be back at 3 o'clock.